Watch this coffee cup. It sits on a table, steam curling up, a hand reaches in to lift it. A few seconds of footage and nobody filmed it. No table, no cup, no camera. You typed a sentence and a machine painted the whole scene into motion. Now look closer at where these things break because the flaw tells you everything. Watch the cup as the hand lifts it. For half a second the handle is on the left. Then it slides to the right. The rim ripples. The steam stutters. It is the same cup, and then it is a slightly different cup, and your eye catches it instantly. Here is the thing people get wrong about how this works. They imagine the model paints 120 separate pictures and prays they line up. If that were true, every frame would be a fresh guess, and the cup would morph constantly. So the single hardest problem in making video is not painting one good frame. It is making a thing stay the same thing while it moves. Today, how a machine solves exactly that, by refusing to think in frames at all. Here is the mental shift that makes everything click. Stop picturing a video as a stack of separate frames. Picture it as one solid object. Take every frame and slide them into a deck, one behind the other until they form a single translucent block. Two of its faces are the picture you see, width and height. The third face, running back into the screen, is time. A thing that moves is not a sequence of pictures of it. It is a smear, a streak through that block, the same object drifting across all three dimensions at once. This is the whole reframe, and it is the one idea I want you to keep. The model does not make frame 1, then frame 2, then frame 3, hoping they agree. It treats the entire block as a single thing to create, generated all together. So now the question changes shape. Earlier in this season, we watched a model start with a flat canvas of pure static and walk it, step by step, toward a picture. The block is just that canvas with a time axis bolted on. The question becomes, how do you teach a machine to denoise a block of spacetime? Because if the whole block is born together, the handle cannot jump between frames. The frames are not separate decisions anymore. They are one decision stretched across time. But that block is enormous. A few seconds of video is hundreds of millions of numbers, far too big to denoise directly. So the first move is the same trick the image episodes used, compression with one upgrade. Remember the VAE from the GANs and VAEs episode, the quiet compressor that squeezes an image down to a tiny latent summary and back. That is exactly the tool here, just grown a third dimension, so people call it a 3D VAE. For a still picture, that compressor squeezes it into a much smaller stand-in, a latent. For video, it squeezes in space and in time. A handful of nearby frames get crushed into a single thinner slice of latent. That is the crucial difference. Motion is not bolted on afterward. It gets baked into the compressed block from the start, because the squeezing happens along the time axis too. Now, how do you feed that compressed block to a model? The same way a language model eats a sentence, by chopping it into tokens. The image episodes cut a flat picture into little square patches. Here you cut the block into little cubes. Each cube is a small chunk of space across a short slice of time. A cube of the cup is not just that corner of the image. It is that corner moving for a fraction of a second. These are spacetime patches, and the instant you have them, a video looks like something a transformer already knows how to handle. A long sequence of tokens, and one quiet gift falls out. Because the model just sees a bag of tokens, it does not care whether the video is tall or wide, 3 seconds or 8, square or widescreen. More tokens, fewer tokens. One model, any shape. Now the engine. Once the video is a row of tokens, you hand it to a transformer, the exact machine from the language season, except here its job is not to predict the next word. Its job is to denoise. It starts from a block of pure static and over a series of passes, nudges every token toward the clean scene your words describe. A transformer doing diffusion has a name. People call it a diffusion transformer. And this is the quiet reason these models got good so fast, because a transformer scales the way language models scale. Pour in more data and more compute, and just like a chatbot, the video gets more coherent. The cup holds together. Same scaling story, brand new dimension. And it is the very same engine from the painting episodes, not a new one. That same single arrow with 3 names, noise, score, or velocity, learned now over space and time instead of a flat canvas. Most current video models learn it as a velocity along a near-straight path from static to scene, and the older image diffusion math is just the special case of that when the noise is plane and Gaussian, the Gaussian case of flow matching we unified earlier. Cleaner path, far fewer steps to walk it, which is part of why today's models are fast. Now we can finally beat the villain from the opening, and the fix is almost embarrassingly direct. Remember why the cup morphed. If each frame or each short window of frames is decided a little on its own, you get 100 slightly different cups and played in a row that is a shimmer. The cure is to let the patches look across time. Attention is the move from the language season where every token gets to look at every other token and decide what it should be. Now let it reach along the time axis. The tokens drawing the cup at 2 seconds get to look directly at the tokens that drew the cup at 0 seconds and ask, what was this an instant ago? What should it be an instant from now? That single connection across time is what holds an object together. The handle stays put. The rim stops rippling. This is temporal attention, and consistency is not a filter smeared on afterward. It is not motion smoothing. It emerges from letting the denoiser attend across time while it builds the whole block at once. There is a real engineering dial here, by the way. In the most thorough version, every patch in space and time attends to every other one. Gorgeous and brutally expensive because cost grows with the square of the token count. So cheaper models often split the work, attention within a frame, then a separate pass of attention across frames. Faster, slightly less able to track fast diagonal motion. And notice the shape of this story because it is the shape of the whole field. A couple of years ago, jittery AI video was a punchline, melting faces, swimming text, a dog with a shifting number of legs. That was not a permanent ceiling. It was a young technology that had not yet learned to look across time. Once it did, the flicker mostly went away. Go back to that cup and notice something you barely registered. The clink of porcelain as the hand set it down. For years, sound was a separate, clumsy step. You generated a silent clip, then went hunting for a sound effect, then nudged it by hand until the footstep roughly landed on the footfall. It rarely truly matched. The recent leap is that the best video models now make the sound in the same breath as the picture. Here is the mechanism, and it is lovely. Remember that a video became a block of latent tokens. Audio can become its own thin lane of latent tokens too, a strip running right alongside the block on the same time axis. Then a single model denoises both lanes together, in one pass. The picture tokens and the sound tokens are attending to each other the whole time. So the footstep lands exactly on the footfall, the splash on the splash, the lips on the phonemes, not because anyone aligned them afterward, but because they were never separate. They were one creation, and there is a deep reason joining them helps the picture too. Sound and motion are two faces of one event. A model forced to produce both at once has to actually understand that an event happened, not just paint a pretty surface. Now the honest footnote. Exactly how the very newest closed models wire this up inside is not public. The labs publish demos, not blueprints. So when we draw it, we draw the shared idea that the open research clearly shows, 2 lanes denoise together, and we put a plain label on the specific product. Architecture not disclosed. That is just the truth, and a good teacher says so. 2 myths to clear because they are everywhere and both are wrong. First, the model is not stitching together clips it saw in training. It is not a collage, not a search engine for footage, not pasting a real cup over a real table. During training, it learned the shape of how a vast ocean of videos tends to look, the statistics of plausible motion and light and shadow. When you generate, it draws a fresh sample from that learned shape, guided by your words. The specific cup, the specific steam, that exact lift of the hand almost certainly never existed in any clip. It is sampled, not retrieved. Second, the eerie one. When these models nail a believable camera move, swooping around an object that stays solid from every angle, it is tempting to say the model built a little three-dimensional world inside and is filming it. It did not. There is no scene, no geometry, no camera in there. What it learned is that videos with consistent perspective are far more common in the data than videos that warp, so consistent perspective is what it tends to produce. It is an astonishingly good statistical hunch about how the world looks when it moves, and that is genuinely amazing, but it is correlation that looks like 3D, not a 3D engine. This is exactly why the same models still occasionally fumble. Objects that quietly pass through each other. A poured liquid that does not quite obey gravity. Hands, famously, with one finger too many. The physics is approximated from watching, not computed from laws, and that gap is precisely where the seams still show. Now the real frontier, and it falls right out of everything we built. Generating one short block all at once works beautifully, but people want long video, a minute, 10 minutes, and you cannot fit a 10-minute block in memory at once. So for long generation, models switch tactics. They make a chunk, then make the next chunk conditioned on the last, then the next on that one, rolling forward in time. And the moment a model builds the next moment partly from moments it just invented, you have a loop that feeds on its own output. In any such loop, tiny errors do not just sit there. They compound. So push these models long and you watch it happen. The colors slowly oversaturate and bloom. The motion starts to loop. A character drifts. A face that was sharp at second 3 is subtly someone else by second 30. This is long video drift, and it is the active research edge right now, not a settled limit. And the fixes are clever in a way that ties our whole episode together. One leading idea is an anchor. As the model rolls forward, it keeps a firm grip on the very first frames and forces every later chunk to keep attending back to them, so the scene cannot quietly forget what it was. An attention sink, a stake driven into the start of the block that the drift cannot pull away from. So I will not tell you long coherent video is a wall. I will tell you it is the edge, the place the real work is happening, and it is moving fast. The difference between a permanent limit and the current chapter is the most useful distinction you can carry in this whole field. One last thing, and it matters more than any benchmark or leaderboard, and those leaderboards flip every few weeks anyway, so do not anchor on whoever is on top this month. We have just described machines that can produce moving, talking, sounding footage of things that never happened, convincingly. That is a gift for storytellers, teachers, and tiny studios with no budget, and it is a real danger the instant it is pointed at a specific person who never said or did the thing. So the line this field is drawing and the line we hold is simple: consent. You can generate a performance from someone who agreed to be used. You do not put words and actions onto a real human being without their say-so. That is not a style preference. It is the rule, and it is the bright line, full stop. And the world is starting to require honesty about it. A major law in Europe is about to require AI-generated and manipulated media to be disclosed as synthetic, with the transparency rules taking effect in August 2026, and the tools increasingly stamp a hidden, tamper-evident mark into generated footage, so its origin can be checked later. So here is what you actually understand now. A video is not a stack of pictures. It is one block of spacetime, compressed in space and time, chopped into patches, and denoised all at once by a transformer, so every frame agrees across time, with the sound born in the same breath. The next time one of these scenes resolves out of pure static in front of you, moving and sounding like a real place that does not exist, you will know exactly what you are watching. And in the next episode, we do something stranger. We stop pressing play, and we pick up the controls. When a video you can steer becomes a world.